I'll now look at using the curvature cone plot to evaluate surfaces. And we've already used the curve curvature on the edges of surfaces. But in this tutorial I want to use two additional methods. And one is the curvature on the U and V, and the other one is the cross-section editor. So I'll start with the U and V curvature. And I'll take this windscreen, and the CVs show the U and the V directions. So I can use these curvature ticks in the control panel to apply a curvature comb in the U and or the V directions. And to control these we've got this curvature tool here, which opens up the curvature section, and this is where I can change the scale of the cone plot and the number of samples. And down here is the spacing, so if I change that to 2 then I just get a cone plot on each edge. But if I increase this one to say 5, then I've got 5 cone plots in the U direction. And to clear those I just take the ticks off. So this is only useful in specific situations as it's dependent on the U and V flow on each surface. So on this wheel arch we could use it because the holes are showing that the surfaces are flowing in a coherent way. And then we'll get a reasonable result when we apply the U curvature, which is allowing us to compare across these surfaces. And you'll notice here where the CVs are mismatched that it's ignoring that and just dividing up the surface into equal lengths. But it doesn't work so well with this surface that's got hulls going off in a different direction, or if I apply it to this large side surface that's got a completely different flow of hulls. Now this tool and the curve curvature locator work directly on the NURB surfaces, but the next tool, the cross-section editor, works slightly differently. So I'll just use the global setting here to apply an X section across all the surfaces. And then it simply cuts through the surfaces regardless of the boundaries or the CVs and the hulls. And if I now want to apply the curvature, I can just use this tick. And I can control the display of the curvature by double-clicking on here and adjusting the scale and the number of samples. And while I'm here, I'll just reduce the spacing to 250 as well. But I can also control this display by using the curvature tool in the control panel and change the scale and the samples here as well. But the key thing to understand when using cross-sections is that they work on a tessellated version of the NURB surface. So tessellation happens when Alias shades up the surface. So if I shade these, then it takes this smooth NURB surface and then simplifies it into triangles. So this would be a large tolerance, this one smaller, and this one small enough to look smooth. Now we never normally see this faceting, and that's because I've had to specifically set these to show the triangles by choosing flat shade meshes here in the quality section. Because what it normally does is automatically smooth those out for us. And the only place we actually see the tessellation is on the edges. And that's the same on our NURB surfaces. So I'll just make the shading tolerance really big. But then it's not actually looking very bad on the interior because of this automatic smoothing. But you can see just how coarse the tessellation is on this edge. We've got a great big facet there and then 2 big facets there. And this is really important when we're using the cross sections, because if I just apply those sections now, you'll see that they're showing the coarse tessellation and they're not smoothed out. And this is controlled by the diagnostic shading tolerance. So if I now reduce that, then the sections are showing a smoother result. And if I put that back to very coarse again, we can see it particularly when we display the curvature comb. And we might read this profile here and think that there's a problem with the surface, when in fact it's caused by the tessellation. So you need to balance a small enough tolerance so that you get an accurate reading, but not so tight that it slows down the interaction. Now the other really useful thing about using the cross-section editor to examine curvature is that we can create specific sections to analyse different parts of the design. So on this wheel arch, for example, I could create a new radial cross-section by picking an edge that we want to be perpendicular to. And it creates a number of sections along the edge, and I can have more or less, so let's just keep it at 10. And you can rename that, so I can call that rear wheel, and then I can pick the surfaces and apply it. So now the sections are radiating out from the centre of the wheel. And then if I turn on the curvature, then I can evaluate how the surfaces are flowing, regardless of the UV direction or the surface boundaries. Another option I have is to create a planar section. And this takes me into the standard construction plane tools. So I'll just do a geometry plane, and then click on this wheel arch, and I'll just choose the direction. So if I apply that to the surfaces with the curvature display on, then if I double click on the new section, I can interactively move it around anywhere I want to examine a particular area. And I've got controls here to create multiple parallel planes if that's useful, but probably not really what we want in this case. Now all of those new sections will get saved with the geometry when I save the file. So the cross-section editor and the curvature display controls are here on the control panel. But if you want to hotkey the cross-sections or add them to your marking menu, then the editor is also available on the Windows Editors menu. And you'll find more information on using the cross-section editor in the version 2011 update movie in the resources section.